Everyone, and welcome back. It's Amari, your Perpetual Tech Noob, learning more with you. I'm back. You know what we're here to do. Another 1 hour Algo Challenge. As a matter of fact, I'm going to start the clock right now because I'm going in. All right, Stone Game 6. Alice and Bob take turns playing a game, with Alice starting first. There are N stones in a pile. On each player's turn, they can remove a stone from the pile and receive points based on the stone's value. Alice and Bob may value the stones differently. You are given two integer arrays of length n, Alice values and Bob values. Each Alice values I and Bob values I represents how Alice and Bob, respectively, value the ith stone. The winner is the person with the most points after all the stones are chosen. If both players have the same amount of points, the game results in a draw. Both players will play optimally. Both players know the other's values. Determine the results of the game and, if Alice wins, return 1. If Bob wins, return -1. If the game results in a draw, return 0. Okay, can't say that I totally understand that yet, but we're going to find out. The constraints so far. Alice values length equals Bob values length, which is also equal to n. So n is the number n is the number of stones. So that's the amount that's going to be in every array. Right? Now here, that value, n, is between 1 and 10 to the 5th power inclusively. Alice values I and Bob values I are all between 1 and 100 inclusively. So every particular stone has a score between 1 and 100. There are up to, 100,000? Right? 5 zeros. 100,000 stones in the pile. Okay. Let me look through these examples and see if I could get a little bit more insight. Alice's values have 1 and 3. Bob's values have 2 and 1. Now the output was 1, meaning that Alice won, and both players play optimally. I'm sure Alice starts first. So with Alice starting first, of course, she's going to grab the 3. With that 3 gone, that means this 1 is also gone. So Bob has only the 2 to grab. So of course it's 3 to 2, which means Alice won. If Alice takes stone 1, 0 indexed first, Alice will receive 3 points. Okay, how will she receive 3 points? Bob can only choose stone 0. Oh, 1 as in 0 index. That's why they said that. So, what do you call the second item? Alice wins. So in example 2, You have a 1, 2, and a 3, 1. Now, this should be a tie, right? Because Alice, knowing that Bob has better values than her, she won't pick 2 and leave Bob with a 3. She's going to pick the 1, making Bob have to choose the 1 as well, because 3 will be omitted because the first stone is gone. Okay. If Alice takes stone 0, the first in the index, and Bob takes stone 1, they will both have 1 point, which is a draw. Example 3. Alice values are 2, 4, and 3. Bob values are 1, 6, and 7. And the output is -1, which Bob wins. Why? Because Alice goes first. I'm figuring she will take the 3 to have Bob lose out on the 7. And then Bob will take the 6. And that will leave her pulling up the 2. If she took the 4 first, which means he wouldn't have the middle value, and he decided to take the 7, which means now she can't have the last value, and of course after that she takes the 2, then of course she would have 6 to his 7. So either way she will lose. But seeing that they will play optimally, I'm sure she would try to get in his way by taking his highest value, but it wouldn't even matter regardless. Anyway, explanation. Regardless of how Alice plays, Bob will be able to have more points than Alice. For example, if Alice takes stone 1, Bob can take stone 2, and Alice takes stone 0. Alice will have 6 points to Bob's 7. Bob wins. Okay. So, what's my intuition on this one? I'm thinking maybe I should set up a variable. A variable called turns. To remember whose total to add to. Of course, it could start at 1. Odd numbers signify Alice's turn. I have to set up variables for Alice and Bob's total, right? Set up 2 variables for Alice and Bob's total. Now, at the end, what I'm going to do is, instead of returning a Boolean, I'll have to make a if-else statement. If else. Okay, Make a conditional statement for the return. 1 will be if Alice wins. Alice's score is higher. Let's just say Alice wins. -1 if Bob wins. And a 0 tied game. Now, I can make a for loop, right? Create for loop. To choose the best stone for each turn stones stones value depends on whose turn now. I'm gonna have some issues. Let's say in this example over here, right? It's not an issue in this particular one, but I can see that there's a 7 here, and that for her to at least get a 7, she will need these 2 items, the last 2 stones, right? I wouldn't want her to pick the best in her lot, because that will omit this one from Bob's, and he'll be left with the 7. But once he takes a 7, that will take away from hers. So I'm gonna have to think this through to make sure that they will try to sabotage each other as well. Players will grab the stone of the highest value. Highest value from both lists. There's some will the index will add the value of that index from their personal set. Well, it says stone's value depends on whose turn it is, so I guess that's already, well, you know what? How about that? You know how it goes. Pipe's running again. Hopefully it's not too much of an issue. Oh, already 15 minutes. Okay. Grab the index with the highest value from both lists. We'll add the value of that index from their personal set. That's gonna mean extra checks. And not only that, once that index is chosen, we'll omit that index from both lists. Okay, let's try this out. I know I was explaining while I was typing, so, and not to mention jumping around, so it might not be the best explanation, but here we go. All right, first of all, we got to set up some variables, right? So let's say turns equals 1. And we need Alice's total and Bob's total. So Alice total, Bob total equals 0. And then let's create the for loop. I guess this will be a while loop, really. While Alice values, which is a list, while the length of Alice values is greater than 0. How about that? Let's say best stone. What I'm going to say is the best stone. I'm going to look for the highest value stone in both sets. Okay, so how am I going to be able to say if the stone came from Alice's set or if the stone came from Bob's set? Because let's say in this case, if I did that to make it where they're constantly trying to sabotage each other, Alice's turn was first, well, she would grab the best one out of both sets regardless. So she would grab the 3, leaving Bob to take the 2. In this case, let's say Alice took the 1, which is what she's gonna have to do. Oh, those pipes don't play with me, huh? Okay, so I would have to make something to compare the 2 then. So I'm gonna say best in Alice values will be the max of what is in Alice values, and then I'll make another one, which is best in Bob's values, right? To find the best one in Bob, and if Alice has the greater value when you compare the 2, then we know that we're going to be focused more on Alice's list in that meantime. Of course, when it's all said and done, even if the best value was in Bob's, we're going to have to make it so that when it comes time to add it to their total, that we make sure that we add it from the proper value set, right? So let me try this out. Best in Alice values equals max Alice values, right? And we're doing the same thing for Bob. That's how it's spelled, right? Bob values, okay. If best in, how about this? If best in Alice values and best in Alice's, best, sorry everybody. If best in Alice's is greater or equal to best in Bob's, let's say current index. If best in Alice is greater than best in Bob's, current index equals current index would equal the index of best in Alice's from Alice's values, Alice values. Okay, so current index equals Alice values dot index best in Alice's. Else current index would equal Alice values best in Bob's. Right? If turns modulo 2, if turns are even, then we're going to add this value, we're going to add the value of that index. If turns are even, we're going to add the value of the index in Bob's values to Bob total. Maybe I should just put Bob's total. Okay. Alice's total, whatever. It'll make it easier for me. And vice versa. If it's odd, then we're going to add that index from Alice's values to Alice's total. So if turns modulo 2, right, say if it's even or not, is equal, well, no, this is Python. What's wrong with me? Is equal to 1. If it's odd, then Alice's total plus equals Alice values current index. And if that's not the case, then what we're going to do is add it to Bob's total. Not add it to Bob total. We're going to add the index, that current index, its value that's in Bob's values. I'm going to add that to Bob's totals. Bob's total. It's Bob values and Alice values. Alice values, Bob values. If best in Alice is greater than best in Bob's, current index equals Alice values index best in Alice's. And if not, then current index equals Bob values index best in Bob's, right? Now, here's where we add it to that particular person's score, right? We find the index, we add it to the person's score. What we're gonna do now is make sure that both of them lose that stone in their set, right? So let's say Alice values to take that index out. I'm gonna use pop, but I'm gonna use pop with an actual integer in it, so it doesn't just take the last thing. I'm just about sure that's how it works. So we're gonna find out in a second. Alice values that pop current index. And we're going to do the same thing for Bobby. Bob values pop current index. And then, of course, we have to add 1 to the score. Not to the score, sorry. We add 1 to the turn. That's not a point off, okay? I caught myself before I waited too long. Okay, yes, so we're gonna be losing 1 from each one every time. They're the same length, so I only have to worry about Alice's length, right? And for the final After that while loop is done, what we're gonna do is make a conditional, I said, right? If Alice's total, if Alice's total is greater than Bob's total, I'll return a 1. If Bob's total is greater than Alice's total, I'll return a -1, else return 0, right? Because if it's neither one or the other, then it's a draw. So if Alice's total is greater than Bob's total, return 1. If Alice's total is less than Bob's total, we're going to return a -1, else return 0. I want to look this over. I got 28 minutes left. I feel like just running it, but I'm going to look it over. Turns, right? Oh, they don't have the auto? Oh, look, I put turn here, I put turns here. Let's just make this turn. Matter of fact, maybe I should... Come on, stop playing. Turn, 5 out of 10. You. Turn, okay. So I have Alice's total. I have Bob's total to worry about as well. Okay, look like everything's spelled correctly so far. Alice's value. Alice values, pardon me. Okay, so far so good. Bob values. Okay, I don't see anything where things are spelled wrong so far. Current index seems to be written properly the whole time as well. I think I might be good to go. And I said I was going to look over it again, but I'm not. Run it. Ooh, nice, nice. But, well, I guess the only thing to do is check it out, right? Let's go. Let's go. Let's go. Give me 100. You know what I came here for. You know what I want. Come on, LeetCode. Oh, of course. Okay, because I'm looking in the opposite persons. So, in this case, they say that I said that Alice won. They're saying that Bob wins. Because I have Alice. Alice would have grabbed her 2 to make sure Bob doesn't have this 10. And then Bob would have grabbed this 10. Stopping Alice from getting this 6. Right? Alice would have grabbed the 9 to make sure Bob wouldn't get this 9. So, you know what? Let's just say okay, I'm gonna have to put some print statements in there, evidently. Come on, you got 25 minutes. Printing out the current index. What else do I want to print out? I could print out best in Alice's and best in Bob's as well. Best in Alice's. Right, and then I want best in Bob's. Right. So I'm getting their best. I'm finding the current index. And then I could print their current score. OCD, sorry y'all. I'll do it separately. Alice's current score. Alice's total. And then I'll do the same thing for Bob. Okay. Maybe I should print that out too. Okay. Alice's remaining. Alice values. And then I'm going to do the same thing for Bob. And while I'm here, I could say the first thing to do is to print out the turn. Current turn. Okay, let's run it again and try for case 4 and, well, this case here, and see how this turns out. Okay, turn 1, best in Alice is 9, best in Bob's 10, current index is 9, right? Huh? Current index is 9? Oh, you know what? That's another thing. Just to make sure that we have a good separation in between everything going on. In between turns, that is. Okay. 1, 2, 3. Oh, hold on. That's the remaining stones. That is the remaining stones. And how does he still have a 10? If best in Alice's is greater than best in Bob's. Current index equals Alice values dot index best in Alice's. So, first of all, Alice's is 9, Bob's is 10. The current index was 9 though. Let's look at the original. Current index was 9. Okay, so the current index is 9. How is Bob's remaining stones? Why does it still have a 10 in it? And why does hers still have a 2 in it? My pop didn't work? Pop didn't work. Okay. Which is kind of funny that it... So what came out here? Best in Alice 3, so the current index is 1, right? And then it did pop it here, the remaining stones. So let's go back to case 4. How come it wasn't popped right here? Alice's score was a 6. A 6? It would have been the 2, right? That's strange. What did I do wrong? What did I do wrong? Because evidently in other ones it popped it fine, but maybe it popped off the last one because it's popped. So no, because 4 and 4 is still here. 2 9 1 1 1 3 5 8 6. Why here? Why here? No, 8 8. Yeah, 8 8 6 8 6. Why did they pop here? Current index equals Bob values index best in Bob's. Okay, let's say in this one, best in Bob's was 3. Current index is 0. Alice's current score was 1. Bob's current score was 0. Of course, he didn't get to go yet. Alice's remaining stones is 2. Bob's remaining stones is 1. Right? Current index was 1 in this case because that was the one that was the highest, right? Alice's remaining stones is 1. Bob's remaining is 2. Let's say here, two, 4, 3, 1, 6, 7. 7 was Bob's. So current index is 2. Alice's current score was the 3, right? And we lost the 3 at the end, and we lost the 7. Bob lost his 7. As we move further, 2, 4, and 1, 6. Best in Alice's was 4. Best in Bob's was 6. He decided to take his own. Current index is 1. Bob has a current score of 6. Then you're left with the 0 indexes. And of course, Alice did whatever she can after that. So why in this case, if it's 10 and the current index is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Am I missing something here? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, I was correct. Well, the algo was correct with the way I run it. Wow, I'm down to 12 minutes already. Oh, she ended up using her 6. He had 2 10s in there, and I grabbed the first one. I'm over here looking and expecting this one to be grabbed, but he had 2 10s. And matter of fact, it would have been better for her to grab that one anyway, because it had a higher number for her. And the next time, he would end up grabbing a 10, right? So it would have been 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, that's why his current index is 11. And then they both lost that. He lost that 10. Well, he added it to his score, and she lost the 2. So evidently, that didn't work for all test cases. With 10 minutes, I doubt I'm going to be able to correct it. But maybe I need another conditional, or maybe I just need to grab the best in their own particular set. I can do that. I don't know if that's gonna work out, but I can try. So best in Alice's, best in Bob's. Let's say hold on. How about I do it here? Oh, no, but I need current index first. So I'll do it here. So be it. Sorry, this is gonna mess with me. if it's Alice's turn, current index equals Alice's values index best in Alice's, and if not, then if it's Bob's turn, we'll look for Bob's greatest. And in that case, case 2 is wrong. And case 4 is still wrong. Okay. Wow. Okay. Let's see why case 2 is wrong. In this case, it was Alice's turn first. She grabbed the 2. Right? Leaving Bob to grab the 3. And of course. So, it looked like I will have to make some kind of variable to say if their total score, if the sum of what's remaining in their stone pile, in the opposite player's stone pile, is higher than the current player's stone pile, if best in Alice's is greater than best in Bob's, I could say and sum of Bob values is greater than sum of Alice values. Whoops. Well, that would depend on the player's turn too. Is greater than the sum of Alice values if it's Alice's turn and Bob has a greater sum in his stone pile, no. That's 6 minutes on the shot clock. If current index Alice values index best in Alice's current index will be Bob values index best in Bob's. Well, if it's Alice's turn then you'll go for her best. And I will have to do the same thing for Bob in reverse that I just did for Alice. And if it's Bob's turn and sum of Bob's values is less than sum of Alice's values, then you're going to look for Alice values best in Alice's. Okay, with 4 minutes and change left, pray for me, y'all. Wow, it worked out here, but case 4. All right, and you know what? I'll use my 4 minutes, at least try to get some understanding. I'm not going to be able to solve this, understand it and solve it in 4 minutes, but we'll see. Current turn is 1, best in Alice is 9, best in Bob's is 10. Current index was 9. Because if anything, I'm sure I didn't even see the sum of each one. That's something else that I could have printed out. And best in Bob values. The sum of Bob values. I keep doing that. I'm used to pressing the save for my VS Code. Regardless, okay. So Bob definitely has more. You know what? If anything, I wouldn't need it to change every single time because we're going to be taking things out every single time. All right, I'm not going to kill you off with my banter anymore. With 2 minutes left, it looks like this is a failure as well, which is 3 failures in a row. I got my hit back on the last one, but evidently, LeetCode is like, hey, if you're going to be putting this on YouTube, no, we're going to spank you, buddy. We're going to spank you. Do we really have to check the scorecard this time? Without a successful submission, it's an automatic fail. Well, was my explanation timing really that good? Wow, sorry to put you all through that. A whole hour just to watch me flounder around and fail. But hopefully you can learn something from this too. Wish me the best of luck for next time. If you appreciate what we're doing over here, don't forget to like, subscribe, comment, and share. All right, y'all. You know how it goes. Till next time, keep building.